You guys, that is okay. We'll move on. So, help me, is it 25? Math 8?
My other math 30.
Oh, yeah, sorry.
Yeah.
So, several mathematical stories originated with the second wedding of the mathematician and astronomer Johann Kepler. Here's one of them. While shopping for wine for his wedding, Kepler noticed that the price of the barrel of wine was determined solely by the length d of a dipstick that was inserted diagonally through a hole in the top of the barrel to the edge of the base of the barrel. Kepler realized that this measurement does not determine the volume of the barrel, and that for a fixed value of d, the volume varies with the radius r and the height h of the barrel. For a fixed value of d, what is the ratio r to h that maximizes the volume of the barrel? So d is fixed, and we want to know when that ratio maximizes the volume of the barrel. Actually, how do you compute the volume of the barrel?
Pi r squared times
the area
h
of the base, which is just a circle,
times h.
times h, and that's going to be the volume, and we're trying to minimize it.
Don't barrels like bulge out?
What's that? Yeah, you know what, you're right. Well, with Johann Kepler, I don't know if they're actually bulged out then, I don't know.
Because that would be more difficult. Yes, that would be more difficult.
Even if they're bulged out, in this case, it wouldn't matter. If the dipstick's going diagonally at an angle like that, that would be the bulge.
But if one blows more than the
There's
other.
going to be one more.
Unnecessary question.
We got a sidetrack here, so volume equals pi r squared.
So, if we're trying to, it's not that we're just trying to maximize volume, guys, we're trying to do it in terms of the ratio of r to h. Thoughts? In other words, can you and I come in and think of the function v, not as a function in r, not as a function in h, bless you, but actually as a function in r over h? I mean, I think that's the question. But again, keep in mind, d is fixed, and d is the length of the diagonal of this right triangle. Any ideas? What's that?
Well, obviously you're going to have to use Pythagorean theorem or something.
Or something.
They wouldn't have given us a right triangle otherwise.
How's that going to help?
Solve for one of the variables, plug it into the original equation.
All right, I'll do that. I think it's easy to solve for r squared. It's just a and so I think the volume could be interpreted as pi times my r squared, which is this, times h. Yeah, how does that help? Oh, by the way, keep in mind, e is just a constant. It's not changing.
Can we substitute?
Oh, no, because you squared it.
Can we get rid of d?
You know, I can't, but don't worry about it, because it's just a constant like pi. So don't even let that bother you.
So we now have a function with respect to h.
Okay, so we wouldn't get next time. No, you're right. Can I restate your words? He's got a good point. We're now expressing the volume in terms of a single variable h.
Distribute them, right?
Okay, I'll do that. Right?
So you separate d squared minus h squared into like d plus h times d minus h, or d
And I can factor that as a difference of two squares, but does it really help though?
I don't know.
If we take a derivative of it, doesn't that just always
Well, if you guys want me to differentiate, shouldn't we actually take a short break and distribute this h in?
Yep.
So to differentiate, I think that's going to give me, is that 2d's to the first?
No,
No, it's
Two.
just,
zero.
it's just,
2d h.
it's d squared plus
Oh.
a constant
It's just d squared.
minus.
3h squared.
And so I think my derivative function is going to be equal to 0 simply when my d, excuse me, I misspoke again. Simply when my h is going to be the ratio of d to root 3. Didn't you guys say yes to the question? I thought we're trying to find the ratio of r that minimizes or maximizes.
Didn't you say d was a constant?
It is.
Can you go through that differentiation?
Yes, I can. So check this out. Wouldn't I get Or, wouldn't it get that? Or, I'm being silly, my constant happens to be d squared. That's the coefficient of h. That's why I want to differentiate, I got a d squared right now. But you guys, look at my picture, this doesn't answer the question. Because I found the value for h for which I'd maximize volume. How do you find that ratio of r to h that maximizes volume?
Try to plug it back in the original one to get R.
Oh, so you would find the corresponding r value. And if I did that, I see that r squared is equal to my d squared minus my h squared. Which really is equal to a 2/3 d squared. So that I think r in the end will be nothing more than root 2/3 times d. Is that helping?
If we wanna get
Ryan?
Where'd the, like, d squared over, where'd the over the 3 come from?
Came from over here. If this is what h is, then I think h squared is going to be d squared over 3.
Okay.
In my head, I was just squaring both sides.
We did it right.
What's that,
Right?
Brad?
Yeah, this is the right answer.
But we have to answer the question.
If we wanna get R
Oh,
over
I was
H,
talking to
we
her.
put R over
Sorry.
So you just want to look at r over h. So r over h in this case is going to be root 2/3 d over. I've lost it.
D over.
Thank you, d over root 3. But that ends up being square root of 2.
We got the same thing.
What's that, Brad?
Oh, she was just asking me if we did it wrong, and she got the same answer, so it's good. Yeah,
You guys there?
it might have been a different way.
As long as you're happy.
Yeah,
I just want you to be happy.
that way looks easier though.
Well, what technique did you guys use?
It's the same thing what we saw with the R.
Oh, so the original was in terms of R's. But you guys, you know what, you're right. But you see why I was so lazy and I wrote everything in terms of D's? Because I was just trying to avoid those radicals. I just make silly arithmetic errors when I do that. All right. Does that mean everybody's at the same level? I can test you that on what statement?
Not.
If this whole math teacher thing doesn't work out, you got a great career in comedy.
Wow, you guys, there's just not much left.
Don't get us all excited.